Good morning, everybody. Today we're on section 8.2, arithmetic sequences and series. That sounds funny, right? Let me spell it for you. So I'm going to give you a little English lesson. So we have the word arithmetic when we use it as a noun, okay? When we use it as an adjective, we change where the emphasis goes on your vowels. So as an adjective, it is arithmetic. So the emphasis goes here. So this is the arithmetic. It's just the word arithmetic used as an adjective. Sequences and series. So you can guess that they have something to do with addition, okay? Something to do with addition. So an arithmetic sequence is, and I did give you some guided notes again if you want to use them. An arithmetic sequence is a sequence where the difference of consecutive terms is constant. All right, what does that mean? That means if I subtract or add, subtract or add the same number to get from term to term to term. So here, to get from -9 to -2, I'm adding 7, I'm adding 7, I'm adding 7, I'm adding 7. So this would be an arithmetic sequence, and we call this 7 the common difference. So in this case, our common difference would be 7, and we represent that with the variable d. I'd like to take a minute to look at a special feature of arithmetic sequences, and that's the graph of them. So if you think about it in terms of what we were talking about with our domain and range, can you guess what a graph of an arithmetic sequence is going to look like? The change in the x's is 1, the change in the y's is 7. So this has a constant slope. So if I were to plot these points in a scatter plot, I would get something that has a constant slope. So another way to think about this is that these dots lie in a line. Now they don't form a line because there's only 5 points, or an infinite number of points, but it's only points that I am graphing. When I graph them, I'm going to be graphing the points 1, -9. So down here along this axis, I do its place, and along this axis, I do its value. So 1, -9, I'm going to need to go a lot lower. I'm going to move that down, so hopefully, I'm not sure you can even see my -9, but there's my -9. Then I'm going to go over 2, down -2. Then I'm going to go over 3, up 5. Over 4, up 12. Well, that's going to be somewhere up here. So these points, if I had done a smaller series or done my scale smaller here, you can see that these points are going to lie, and if I did a nice graph, on a nice straight line. So you want to remember that the graph of an arithmetic sequence, the points lie on a line. Okay? All right, so let's look at some examples and some counterexamples of an arithmetic sequence. If I have 1, 5, 10, 16, 23. Okay, this is an example of something that is not an arithmetic sequence. It has an addition pattern, but it's not constant. So to get from here to here, I add 4, then I add 5, then I add 6, then I add 7. So there's an adding pattern, but this number here is not the same. So this would not be an arithmetic sequence. Here, instead of adding, I'm subtracting 3. But you can also think of that as adding a negative 3, right? So this is an arithmetic sequence, and whether it's finite or infinite. Okay, and here our D would be negative 3. Our common difference would be negative 3. So notice that if I have something that's decreasing, I'll have a negative D, and the example I gave before, when it was increasing, we had a positive D. All right, how do we, as I told you yesterday, if we can recognize that it's an arithmetic sequence, and it falls into a pattern where it's very easy to write its rule. All right, so if I'm given a sequence, an arithmetic sequence, to find its rule, it's always going to look like this. We take the first, we did this yesterday. You take the first term, then you add the common difference. And how many times did we remember that we added that common difference? 1 less than its place. Excuse me. So it's the first term plus whatever the common difference is. How many times? 1 less than its place. So when we're doing this formula, the numbers we need to fill in is this number and this number. This means, right, a sub 1. If you don't remember, that means the first term. And this means the common difference. We're going to leave this and this because this is for the general n. Okay, for the general n, so that doesn't change in our formula. All right, so here's an example. So if I have this, okay, I have the arithmetic sequence 7, 10, 13, and 16. Confirm that it's an arithmetic sequence. Yes, the pattern is to add 3. All right, but again, this is the recursive rule. No, this is not the recursive rule. The recursive rule would say take the term before and add 3. We want to write the explicit rule. And so the explicit rule says what I do from 7 to get the next number. So if I started at 7, to get 10, I would add 3 1 time. To get to 13, it's the third number, so I'd add 3 2 times. To get to 16, it's the fourth number, so I'd add 3 3 times. So that is our rule. The first term 7 plus, this stands for 1 less than its place, times 3. times the common difference in this case. All right, we do want to go ahead and simplify that. So that would be 7 plus 3n minus 3, or 3n plus 4. All right, so now if I wanted to find the 20th term, if I wanted to find a 20, I would just plug in 20 for n. So the 20th term here would be 64. So I don't have to continue this pattern out 20 times. I can skip right ahead because my formula tells me what to do with the first number and then how I can get to the 20th number. All right, let's do another example. All right, again, this is an arithmetic sequence and my common difference is -7. I am subtracting 7 to get from one term to the next. So my rule would be the first term, 15, plus n minus 1 times the common difference in this case, which is -7. So if I simplify that, I get 15 plus -7n plus 7, or I get 22 minus 7n. You could also write that as -7n plus 22, whichever you prefer. So again, if I wanted to find a 20, I would just have to plug in 20 for n. So I get 22 minus 7 times 20, 22 minus 140, so I would get -118. All right, that is how you find the rule if I give you the sequence. You can also find the rule if I give you just the common difference in a term, if I give you 2 terms. So we're going to go over those examples as well. We're going to go ahead and go over those examples in the next video.